Alright, so just to remind me about arithmetic sequences, while we're getting our books out. Anyone remember the formula off the top of the dome?
Tn
Equals
T1
very good.
in bracket plus in brackets n type 1
Yep,
times by b.
very good. Sophie's been around. So Sophie knows the equation. Does anyone want to help me out with what the values are? Or the unknowns? Yep, nth term, good. What about our n value? Number of terms? And what about T1? Yep, first term or initial term. What else do we use to describe, what do they use occasionally to describe T1? What else do they call it? Very good. And the D? And how do we know we're dealing with an arithmetic sequence? What are we looking for? What pattern do we want to see? Is this an arithmetic sequence? Need a third term, very good. Is that an arithmetic sequence? How come? I've got a different difference. That's plus 2, that's plus 4. What am I doing there? Multiplying, so that's not okay. What about if I was to go something like 3, 7, 11? Yep, is that okay or not? And what's my D values? And what's my T1? Cool. And if I wanted to know the value of the fifth term, what's the variable I'm trying to solve? So if I was to write, we might do this now, determine the fifth term for our sequence. And I know my writing's small, but you can hear what I'm saying. So determine the fifth term of that sequence. I'll give you 20 seconds. Sweet. Now, one of the things that I've noticed we're struggling with, is I want us now not to determine the fifth term, but to determine the nth term of the sequence. So, if I say the nth term, are we ever going to reach that or not? So what should our final answer have? Any ideas? Should we have a number by itself or not? No. What's going to be left in it? What letter? The letter N. So we should see the letter N in our final answer. Just the letter N. So if I go Tn equals, and I want you to put in what you think, should go where it goes. Same sequence. So T1's still 3, correct? Happy with that? Do we know what our n value is? Do we know n or not? No? Do we know a difference? Yes. What is it? Yes. Can we do anything with that? What can we do with that? What if I put the 4 at the front instead? Right there. What can I do with that 4? I can expand it in, can't I? So I'd get 3 plus 4n minus 4 equals Tn. What can I do with that? Starts with C, ends in elect-like terms. Elect-like terms, very good. So what are my like terms? What are my like terms? 3 and negative 4. So I've got 4n minus 1 equals Tn. Now using that equation, let's just check if it works. I know the fifth term is equal to 19. So if I let n equal 5, what's that equal? 4 times 5? Minus 1? Does my rule work? So that's what, when it says the nth term, it's just asking for a rule for Tn where we've still got n left in it. Sweet? Does that make sense? And the last thing I want to talk about that we did last lesson was this idea, and I didn't probably explicitly go through it as much, probably just for granted understanding, is that the difference is any term minus the previous term. So any term I can pick on my sequence minus the previous term will tell us the difference. Does that make sense? So if, as an example, if I could use my third term minus my second term, or I could use my second term minus my first term, and that will give me the right equation. So 11 minus 7, 4, 7 minus 3, and it doesn't matter which term I pick because for an arithmetic sequence it always needs to be the same amount the whole way. Cool? Happy with that? Who's feeling comfortable with arithmetic sequences? We can find any variable, we can rearrange. Sweet? Good. So there's one more equation we need to learn, and the process is very similar. You understand the concept, it's just the equation. And that's where rather than asking for a specific term, it's asking for the sum of the first 7 terms or whatever it might be. I'll give you an equation, the equation's on. So that's obviously one of our equations that we need to know. And I like this equation because it's nice and in my head I understand what it means. What does that look a little bit like? What does that equation look a little bit like? Nothing you've ever seen before? What if I wrote it in a different way? I'm just going to run a list instead. What's the second part of that equation look a little bit like I'm doing? Average. People see that? I'm taking the average of my first term and my last term. And I'm multiplying that by n. Now these go up in the same manner every time, correct? So if I've got my first term and my last term, we think about it like a shape. What's the area of a triangle? So let's just say my sequence starts at 0 and finishes at, I don't know, 20, and there's 10. What's the area of that shape? How far has it gone up? How far has it gone across? Half base times height is? 100. What's 0 plus 20? Divided by 2? Times 10? We're just taking the average of those two numbers, correct? They're both 10 by 10. That's what a triangle is, sweet. So that formula for me makes a whole bunch of sense. We're just taking the average term, and multiplying it by the number of terms. Cool? Now that equation is represented in a lot of different ways. I'm going to show you, I would rather you learn this rule and pretty much only this rule. Why? Because you've only got so much mental capacity. We can't remember all our Taylor Swift lyrics and all the formulas we're going to see, and we obviously know which one takes priority. Haters gonna hate. Hate, 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 hate. So rather than learning 5 formulas and try and remember my Taylor Swift lyrics, what's wrong with Carla? Oh, I see. I'm the problem. I like to learn that formula because everything in that formula I can find. Now let's say I don't know my nth term. Let's say in this situation, so I'm using the same sequence, I'm asked to find the sum of the first what? Give me a number. 6 terms in the sequence. Have a go. Do we know T1 from this sequence here? Do we know T1? Do we know N? What's N? 6. We got the first 6 terms, so N6, correct? What don't we know? Tn. Can I find Tn? So step 1, before we do anything else, tell me what Tn equals. See how we go. How long do you reckon you need, Kevin, for that? Great, 20 seconds. He didn't say that, to be fair. He said, I'm not sure. I just put words in his mouth. Not yet. Not yet. You will have to rearrange later, but starting up.
Yeah, it is still 3711.
Yeah. Who got 23? Good. So I know Tn, I know T1, I know N, I know everything in this formula, correct? So I just sub in my values. S6 equals 6 times 3 plus 23 over 2. What's 3 plus 23? 3 times 26 equals 78. Very good. Check. Don't take my word for it. Let's keep doing the sequence. This one is 15, this one is 19, this one is 22, correct? Nope, 23. Good from me. Can't even do basic addition. 3 plus 7. 3 plus 7. I'll just do it black above it. 10 plus 11. 21. 21 plus 15. Well, 36 plus 19. 55 plus 23. Works out. Sweet. Happy with that? Now, I do owe you the responsibility of showing you both formulas. So Sn equals n on 2 times by T1 plus Tn, and then I'm going to replace that with T1 plus n minus 1 d. I collect like terms, n over 2, 2T1 plus n minus 1 d. That's your formula, or you can just remember that one. Formula sheet, on your formula sheet. Sweet. Happy with that? So we're going to charge off onto exercise 1.4. Wish I hadn't rubbed these off. 1.4. I'll let you know what questions. I've just got to have a look again. Sweet. Grab your textbooks. Let's get started.